Hello, my name is Andrew, and I'm here to show you guys my newest project. I've been making a Mandelbrot Zoom generating program written in C++ and Python. The C++ handles all the input and output, and the Python handles all the input and output, and the C++ handles the number crunching, because that's what C++ is good at. So I'm going to show you guys a little bit about how it works, make myself a little smaller, tuck myself into the corner so you guys can see what's happening here. Alright, so let me just show you guys an example of a finished video that's produced. This is an example of the output here, zooming in on a part of the Mandelbrot. And the way this works is uses FFmpeg to collapse a bunch of BMP images that were written with a C++ library called EasyBMP, which I got off the internet. And Pygame is used for the input-output, and then SciPy is used for cubic interpolation. I cubically interpolate both the colors and the path targets. We'll see a little bit more about what that means later. But yeah, that was an example movie of what this thing can produce. Here is the folder. Here's the program folder with all the important files. Path Picker is the main file here. So if we want to run the program, we'll go over to a terminal and we will just do Python 3 path picker and run him. And then it asks for inputs, how big our image is going to be in pixels, and then it asks for the name, so we'll say demo movie 2. Alright. Nope, I messed up. I am running in the conda environment, and just clear that. Conda deactivates. There we go. Now if we run it, Pygame doesn't like virtual environments. So if you guys download this and run it, you're going to have to deactivate any environments that you have, any Python environments. So here is the interaction with Pygame window. And then if we click, it moves the target frame and generates coordinates. You see here in the console, it generates the coordinates. And if we move over here, it writes them to a target.txt file. You see it has coordinates written and a little bit of extra information, like the movie title up at the top there. And then if we press Z, we can undo any choices we made and go back. And now if you see, if we go to targets.txt again, there's less coordinates. So it's being written to live by the decisions we make in the interaction thing. If we want to zoom in, we hold I. And if we want to zoom out, we hold O. And I'm actually going to go all the way back to the beginning here. Press Z a couple times and choose a path for a short little video here. So if we zoom in here, and we zoom in here, there we go. And then when we're done, I'll press D, and the input-output will close. And then if we go to the console, it'll start printing out percentages for how far along it is generating the video. So let's take a look at the flow of the program while that's generating. So we start with Path Picker. Path Picker, we'll look at the code here in Ammon here to make it a little bit easier. If we go to the top of Path Picker, it gets user input here. Then it sets up some variables. It writes out to the files. Then it calls generate image, which is a C++ executable, which creates images given coordinates. And those images are displayed in the Pygame window. So we see Pygame here. And then while running, it calls generate image. Here it deals with mouse inputs. Here it deals with Z, key input, pressing Z. Here it deals with pressing the D key. It closes the Pygame window when everything's done. Then it smooths the path out. And then it calls the generate movie C++ executable. And then it opens the movie once you're done. If we go over here, we see we are 51% done generating. We can take a sneak peek. If we look at movie images, these are where all the BMP images get stored. And if we scroll to the bottom, we can see it generating new images live as we go. 36 has been generated, 37, 38. And then if we look at frame coordinates.txt, okay, we'll just open an atom then if it doesn't want to cooperate. Here we are. These are all the coordinates for each individual frame, which gets generated by pathsmoother.py. It turns the targets here into the coordinates at however many frames per second. So the targets times the frames per second is how many coordinates go into the frame coordinates.txt file. So we got 91% done here. And then when it's done, it'll open up the video and we'll be able to see it. The C++ code is here. Here is our finished video. We got demo 2. We can play it here. And you see it zooms in just like we asked it to. So that's pretty cool. Here is our C++ code. We have the generated executables here. But we can look through this just to see what's going on. And all of this will be on GitHub, so you guys can too. So yeah, C++ code. We have the EasyBMP library, which creates the images. And then generate image here and generate movie, both build into the executables. And then Mandelbrot is a class that's a helper class. If we look at the .h here, it does things like setting the frame position to a different location, rendering a frame. It also loads the colors. That's a cool thing to note. You can take a look at the, here's the text data for the color palette we're using. And then that gets loaded into C++ program, and it generates a BMP, where are we here? New palette image.bmp. This is the palette image that gets generated, and it shows you the colors you're working with in your finished video. Yeah, so that is how the program works. But here I have a little folder with all the historical videos that this program has produced, so we can take a little look at how the program has evolved here. This is the first video I created with it, showing translation. The little Mandelbrot guy just moves up into the right. Here's the first video I made showing zoom. It zooms in a little bit on this wacky color scheme, Mandelbrot. This is one of the first videos where I have an interesting color scheme. We get this little corrupted black and white scheme going here. Close it out here. This is one of the first videos where I get the current color scheme working with the blues and the oranges. Here's an alternative color scheme I was messing around with for a while, which I liked, the red and the blues. Here is an example of jittery movement before I started cubically interpolating the targets. You see it has like these like sharp changes in directions because it's just moving in a straight line between each target that's been specified. You get this jitteriness as it moves between targets. And then here is one of the videos where I get the cubically interpolated movement between the frames instead of the linearly interpolated. And you see we get acceleration and deceleration, and we move in curves around corners, and it looks much, much prettier. yeah, so those are all the videos leading up to the current version, and I have had a lot of fun with this project. I've learned a lot, and um, yeah, that is my Mandelbrot. That's my Mandelbrot generator. I hope you guys enjoyed, and thank you for watching. Bye.